Alrighty, what's going on, everybody? Welcome to Beyond the Forecast. We've got the whole crew here
hanging
with us
hanging
today.
on an afternoon, a hot afternoon.
On a hot day.
It's so hot.
It's ridiculous outside.
A couple months ago, we had snow on the ground, and now look what we have. Nothing.
It wasn't just a couple months ago on the ground. Yeah,
Crazy
Now
how-
it feels like we're swimming through the air.
Crazy how things change here
Both
in
of you-
Hampton Roads.
Both of you
love
like
it.
paddling out. We like
Yeah,
warmer water,
of
so
course.
I am excited that the water's getting warmer. Don't need a wetsuit anymore.
The one thing I was thinking, though, this past week with the heat incoming was Jeff's going to hate this.
Yeah.
Jeff is going to hate this.
That's
I
okay.
think most of us do.
time.
We're going to play devil's advocate. We talked about this yesterday. We had southwest winds today. We have them in the forecast next couple days. The water was not as warm as it felt a couple days ago this morning when I was walking the dog.
You know what that's
A little
called?
bit of upwelling.
A little bit of upwelling.
A little bit of upwelling,
Yep.
yeah.
I noticed that too, and then I surfed yesterday, and it was back to warmth. The water temperatures can fluctuate
Yeah,
as much as
maybe
our
that's-
weather
yeah.
can.
By
Yeah.
almost 10 degrees
Yeah,
when you
oh,
get the upwelling.
yeah.
Easy.
Easily.
Love it.
Yeah. So this episode is going to be all about your questions. This is the viewer
This is a fun
question
one.
grab bag. I've been looking
Yeah.
forward to this episode for a long time.
Mostly because we don't have to prepare any big visuals. We could just hang out and
Yeah.
and talk to y'all, the viewers, and answer some of the questions and just chit chat about weather.
And
It's
see
great.
and see how much we know and what we maybe need to learn.
Yeah, maybe we should have done a little bit more
Yeah.
homework. Yeah.
So we have a lot of questions. If you always want to comment on the questions, you can just email it to us. You can put on our Facebook pages when we answer these questions. We're not theming this episode for any particular topic, so we're not just focused on hurricanes or thunderstorms. We're just
Or
doing
heat or
everything.
anything. Yeah,
Everything.
anything and everything. And that's what's been fun about the questions that we have gotten. They've kind of ranged all over the place, from specific things related to forecasts to
Yeah.
specific weather events to schooling to
Yeah.
decisions, all that kind of stuff. We're going to do more of these throughout the next several months and as long as we're doing Beyond the Forecast
Yep.
and Wavy Plus. So if you're watching this and you think of a question in mind, as Jeff mentioned, find us on Facebook. It's probably the best bet, Facebook, or email it to us at weather@wavy.com. Super easy. That
Yeah.
goes to all of the meteorologists and just say, hey, question for the podcast or question for Beyond the Forecast.
Yeah.
And
Yep.
let us have it. Let us know your name. And then we're going to do a lot more of these. Maybe, once a month, maybe. I don't know.
Hey,
I don't
Once
know.
every
Either
couple
that-
months.
Either that method or social media.
Yeah,
Social media is
social
really
media.
the easiest
Yeah.
way nowadays. So, why not?
And while you're at it, give Brian a follow on Facebook.
Yeah.
Got to bump up those numbers.
We're going to start with a good one.
Yeah.
One that we all learned from Jan Gunter. What's the difference between a partly cloudy day versus a partly sunny day? Who wants to
Love
take
it.
this one?
Oh, I want to take this
Okay,
one.
you got
I want
it.
to take this one. All right, it's easiest to think of it this way. Partly cloudy means that only parts of the sky are cloudy, and partly sunny means only parts of the sky are sunny. So intuitively, you would think partly sunny means more sun, but a partly sunny day has more clouds than a partly cloudy day. So I think the scale goes overcast or cloudy, then it goes mostly cloudy because most of the sky is cloudy. Then it would go to partly sunny because only parts of the sky are sunny. So there's still a little more clouds than sun. Then it flips to partly cloudy because you have only parts of the sky are cloudy. So now there's a little more sun than clouds. Then you have mostly sunny because most of the sky is sunny. And then you have sunny or clear. No.
That's it.
No. All right, I got
There's
it.
no
Nailed
trick.
it.
That's
Yeah,
it.
I would say so.
All right.
I would agree. That's
Yeah.
it.
Yeah, that's the best way to look at it, Jen, is say parts of the sky are cloudy. So that means there's more sun because only part of the sky has clouds in it, and only part of the sky has sun in it when it's partly sunny. So it's kind of backwards because you would think partly sunny would have more sun because
You would think
sunny
so,
it
'cause
has
the word sunny in it.
It has the word in it.
But it
and
does
could
not.
be
It's
misleading.
It's not. It's
Yeah.
because we listen.
I don't use the term partly sunny. I never use that on air.
I don't think
Oh,
I
really?
would either.
No,
yeah.
because that's where the question comes from. It's too
Right.
confusing. So I try to eliminate confusion. I'll say it goes from partly cloudy to mostly cloudy.
Mostly cloudy. That transition.
I don't have the middle one.
Right. I think it definitely, from a
about you?
messaging standpoint, I think it could be a little easier. Not as many phrases to remember.
Yeah.
I would say I'm probably similar to Jeff in that aspect. Then I'd probably go partly. I'm trying to think back. When's the last time I said partly sunny?
So what does fair skies mean? If someone says
yeah.
fair skies.
Fair skies, I think would
Friendly?
be
Friendly skies?
When I think fair skies,
I think friendly.
more towards the mostly sunny
True.
than partly cloudy.
But is
Yeah.
are fair skies between mostly sunny and sunny, or are they between partly cloudy and partly sunny?
I think between
Or between partly sunny and mostly sunny?
when I think of it, the
Or
immediate
partly cloudy and
thought,
mostly sunny. See, now I'm confusing myself.
I'm
See, I'm
gonna-
going off rails here.
I'll tell you a secret. I use the term fair skies mostly at night and mostly when I don't know what the sky condition is going to be.
at
And
night
as long as
too.
I know it's not going to rain.
That's what I use. That's why I always chicken out, and I'll say mix of sun and clouds.
yeah.
Yep.
That's it.
Passing clouds.
Or I always no, you called me out because I always say passing clouds.
Me too.
Because it'll be a nice bright day with sunshine, and you'll probably get a lot of sunshine. There'll be a few passing clouds throughout the
Yeah.
day. Maybe there'll be a little bit more passing clouds throughout the day. Yeah,
I like the term mix of sun and clouds. I do. I
Yeah,
say
that's a
that
good one.
on
Yeah.
the daily, usually, especially around here in the summer, we always get that afternoon kind of
and
heating.
there'll
cumulus.
be more sun for a certain portion of the day
Yeah.
than a couple hours in the afternoon. So, yeah. I think I think all three of us here safely can avoid. I think we all avoid partly
Partly
cloudy
sun-
and partly
partly-
sunny because it's so
Yep.
confusing. I confuse myself here just talking about it.
I think I'm going to do that on the newscast tonight. I'm going to say
That's
it's
your
partly
challenge.
Sunny. Yeah,
I
partly
will-
sunny. And then just blow everyone's mind.
Does
Maybe
that mean
not.
I have to? No, we're going to hold you to it here. So we'll figure out what newscast Jeff is going to use.
I also have some other things that I want to talk
Yeah,
about
but you
too.
can't. But I don't know if you can because do we have partly sunny skies in the forecast?
We
no, we
don't.
have sunny skies.
Yeah,
in the
we do.
forecast.
We do. That's true. And that's going to be for like the next week.
Yeah.
So a lot of sunshine.
So it's now choosing between mostly sunny and sunny,
We can work on our terminology
or
here.
fair skies.
Yeah. We can work on our
Jan,
terminology.
thank you
over the
so
next
much.
week.
That's a really fun one.
That was fun.
I guess just think of it as that scale: cloudy, mostly cloudy, partly sunny, partly cloudy, mostly sunny, sunny. Or you flip it the other way.
Or you can flip
Yeah.
it the other way.
Yeah.
Now we're going to do some atmospheric physics. If you remember this from your cloud physics class,
What
this
a
is from
fun
Czech
one.
Owens. I love this question. Do raindrops of different sizes fall at different speeds?
This is great.
You have to account for two things: force of gravity and air resistance.
But force of gravity doesn't change,
You're right.
so that's always going to remain the same.
The same.
So
Well, technically it does, but we're not going to get into that. That's orbital physics and that's other
thing
things.
with
on
a lot
Earth,
of-
On Earth, 9.81
On
meters per
Earth.
second
Sorry,
squared.
they were
We're just going to go
clarified.
with that.
And here's why this is kind of a challenging one for us as meteorologists too, because a lot of times in these classes they say neglect air resistance. A lot of times when we're taking these classes, they have us.
It'd be too
and that's
complicated.
Yeah.
number two.
Yes.
And that's number two, air resistant. And that's why the answer to this
big
question.
factor.
Did you watch the Bill Nye episode a long time ago where he had the
Probably.
bowling ball and the feather and they drop
Oh, yeah.
in a vacuum?
Oh, yeah.
Yeah, they fall at the same speed.
Same speed.
So if Jeff's saying if you neglect air resistance, because that's the two things we're accounting for,
Mm-hmm.
gravity and air resistance. So if you take out air resistance in a perfect vacuum, all your physics
Yes.
equations from Dr. Jennings' physics class in high school, you just can go through the formula and do it. But then once you throw in air resistance and friction, everything
gets messed
starts to
up.
change.
Yep.
So now, without air resistance, if you dropped anything, everything would fall at the same rate without air resistance.
Correct.
Yes.
Because
Correct.
of gravity. Introducing air resistance, a bowling ball and a feather in a vacuum fall at the same rate.
Yes, they do.
With air resistance, they don't.
They do not.
A
So a
feather's
raindrop,
going to take,
right?
Yep.
Air resistance.
and a bowling ball is going to slam down to the
Yep.
ground.
But a raindrop of a large raindrop compared to a small one will fall at different rates with air resistance. Of
course.
Think about those misty, drizzly days.
Where the mist blows.
Yeah.
It kind of just woo.
Yes.
Wafts
Or
to the
sometimes the
ground.
rain. Yeah,
Yeah.
exactly. It's not. It's just kind of misting on you.
And then those big drops, it just seems like they're pelting the ground.
Yeah.
So this is maybe going back to the origins of the question: why do the drops vary in size?
size.
Because when we're thinking of a cloud and we're thinking of the process of rainfall through collision and coalescence, we are colliding those droplets inside the cloud.
Mm-hmm.
Let's say it's heavy enough to fall. As it's falling faster than the smaller ones. Air resistance,
Yes.
once again, it's getting larger and larger. But as a drop falls, it's not like, I don't have a picture of a raindrop, but if you search what a picture of a raindrop looks like,
gonna
it's
draw
not
it.
that shape of the pointed top and the bottom being kind of bulbed out.
No, because it's still in the cloud.
Or-
is that what you're saying?
No, as it falls from
As
the
it
cloud.
falls from the cloud.
It
Yeah,
doesn't
yeah.
look like the raindrop
perfect raindrop.
illustration.
Yeah, it's not the
Illustration.
it's not the clip art that you'd usually see
Right.
online.
It can fall almost in the shape of a sphere or like a hamburger as it's falling.
Yeah.
Or it just kind of does like a
Yeah,
And
so-
that's because of the air resistance.
Right.
And
So
what
as
it's
it-
traveling
working
through.
against the force of gravity. Your force of gravity is going down to the earth. Air
Right.
resistance is working against that force.
And as it hamburgers out, flattens out, it can separate into smaller droplets.
drops.
So this process continues as the raindrops are falling from the cloud.
So there could be a larger raindrop falling, check Owens, and then all of a sudden it splits off into two, and then maybe they're falling at a slower rate because they're lighter and they have a little bit more air resistance to them, and they're not falling as fast as they were if they were a big, thick raindrop coming down to the ground.
Yep. It's so cool.
It's really, really fascinating. It's really fascinating.
Did you do well in that cloud physics class? How was that class for you? That
I
was a
don't
tough
even
class.
think I took a cloud physics
You
class.
didn't have to take the cloud physics at Penn State?
No, I had a. Well,
I did. Cloud
you
physics
did.
was challenging, definitely challenging, and especially since you have to take thermodynamics first and atmospheric dynamics before you take cloud physics. Cloud physics is a really tough one because it's putting together all those classes before it, which
Yes.
are
Yeah.
two of the hardest classes in
Yeah.
the field. A lot of times in the beginning they have you, again, back to what I was saying before, neglect air resistance, but at some point you have to
have to put it-
theorize.
yeah.
You have to kind of theorize what would happen when you put that into play, because that is obviously our world as we know it.
Yeah.
We have to
Yeah.
account for air resistance in
Yes.
So-
our case.
So Brian and I had different focuses to our Bachelor of Science in Meteorology.
Oh, there's different, like, sub-focuses?
Yeah, his
Yes.
was
Oh,
the
I know
focus.
there's
that.
His was the focus in
Yeah.
communication and broadcast,
Yes.
and mine was the focus in, they call it weather risk management, and it was basically
Oh,
like how the weather
cool.
affects the stock
Yeah,
market. So I
there's-
was kind of taking more of like.
A business.
I took a bunch of, and they called them energy, business, and finance classes, and kind of that
Okay.
stuff. Thought that's what I wanted to do, and then I found
Yeah.
out how fun a green screen was, and here we are.
Yeah, I would say I knew from the beginning how fun the green screen was.
Yeah,
so
of course.
I went
But so
through.
some of the requirements are a little bit different. So
Yeah.
that's why many
see.
of us, and it may
Oh, I
have
didn't know they
changed.
did that.
I don't know, may have changed.
I
in the
always
past
enjoyed
10
the
years that I've been there.
forecasting and then bringing the forecast to the television or
Yes.
to
Yeah.
whatever media group it was.
Because now we get to answer all these fun questions.
Exactly. And a lot of times, I know some friends of mine who are now working through grad school, and they crushed cloud physics.
Yeah.
They loved cloud physics. Where me, I was just like, pulling
I did my
pulling my hair out.
my senior thesis research project involving cloud physics, and with Dr. Wu, that was our professor in that. So I did cloud seeding and how does
Oh,
that
neat,
work.
neat, yeah.
We could maybe do a topic on that another time because
Oh,
I
yeah,
don't want to
that's
get
a
too far
yeah,
off.
that's a big one.
It was
That's a big
big,
one.
but it was
yeah.
it's fascinating.
Have to
If
bring
I
up
didn't go
chemtrails
into
then.
broadcasting, I probably would have done grad school focusing on cloud physics and raindrop size. It's just it's so cool.
It's really neat.
Yeah.
It really,
But
really
it's
is neat.
so-
and aren't clouds the most HD thing you see out there?
It gives depth to the
It is
atmosphere.
the
Yeah.
most high def. When you see those
Yeah.
thick summer cumulus clouds,
I was just about to
and
say.
they're like, and if the lighting is right here, maybe it's not super, super bright. Maybe it's later in the afternoon, so the sun's low on the horizon, so you have more of a softer light, and you can see the shadows in the clouds, and you're like, that is the clearest, crispest, like most HD thing you'll ever see. Like the most high definition thing ever.
That is the
But then
thing
the
I
closer
love.
you get to that cloud, it's all
Yeah.
just foggy. You ever think
That's-
about that?
yeah,
When
that-
you're
yeah.
when you're in fog,
Yeah.
when you're in fog, or you're looking at a cloud and you see the sharp edge to like the top of a towering cumulus or something, and it's just not cloud, just right
Yeah,
there.
right.
But on the ground, when you're in fog, you're in a cloud,
Yes.
and it's just
Yeah.
the end
Think
of that
about-
cloud. It's on and off, but it's more of a gradual
It is.
gradient.
Yes, it
You
is.
know,
You're
so
right.
it just kind of
This
slows
is a
into
fun-
it, slows out of it. It's really
This
fun.
would be a fun experiment. Next time anyone's flying and you're flying through clouds, just maybe if you have the window seat, look out the window and watch that progression, because as you start to enter the cloud, it's not this boom,
Yeah.
you're into the cloud. It's a slow fade. You kind of notice it gets a little bit misty,
Yeah.
a little foggy, and then you're fully in it. It takes a little bit of time.
Yeah, but your perspective, seeing it from the ground, looking up so far away,
Yeah.
the edge of it looks super sharp.
Yeah, there's a gradient
Yeah, yeah.
to it.
Yeah.
That's cool. We're going to kind of take that question and what we were talking about with school and college into this next one from Tina. How long is meteorology school? So for a
It
base,
depends.
yeah, it really
It
depends.
depends.
And it depends on where you want to go.
Sure.
So
Or what
for
you wanna do,
broadcast
yeah.
meteorology, 4-year degree
4
is
years.
Yeah.
sufficient.
Yeah, I would say the majority, I guess, of people in our position, it's a 4-year Bachelor's of Science degree in meteorology and atmospheric sciences. That's at least what it says on ours from Penn
Yeah,
State.
yeah.
There are some out there that do there's a certificate program. That I think that's 2 years of just big time weather classes and communications class. It's actually
Isn't it a master's program?
it's
I thought it was a
I believe
master's
there's
program.
a master's program, but there's also a certificate program at Penn State. I'm not sure if to be a meteorologist on air, I don't know if that covers the requirement. I just
Probably.
know that that's another option
Probably.
that some meteorology students take. But then if you want to get your master's or your doctorate,
Right.
that
Yeah,
takes
it
several
goes
more
on.
years.
Yeah.
I have some friends who I graduated 2 years ago. I have some friends who a couple of them want to earn their doctorate, they are going to be in this for a good little while. But the
Yeah.
good news is they love it.
Yeah.
Yes.
So it's at least 4 years.
Those classes
Yeah.
are so
It's at
tough.
least 4
Those
years.
advanced
So
ones,
tough.
grad students. Whew. It's
Oh.
advanced stuff.
Yeah.
It's cool. It's cool stuff,
too
but
much.
that's too much. And going back to the question that we had about raindrop sizes, this is from Kimberly. I like this one a lot. Kimberly Thomas says, could you please explain what a microburst is? So
Love
going
it.
back to the raindrops, as they're falling, they're pulling the air down with it. So we're thinking of air moving downwards. We're getting microbursts in a thunderstorm.
Yeah.
That's where they come from.
What goes up in a thunderstorm must come down. We have you'll hear us call them updrafts in thunderstorms here. That is the warm air rising, but rising very violently to help form the cloud. It rises, it's forced to cool, it's forced to condense, then you have the cloud forming, and then the rest is history. But what goes up has to come down, so you have that sinking air on the other side of a thunderstorm that's pulling those raindrops down, as Jeff was mentioning.
What creates a stronger chance for microbursts or downdrafts? We have to think about the layers in the atmosphere. So if you're thinking of, we need to get like a 3D model of a cloud that we can bring in here every time that we could like slice in half.
awesome.
We got to do that.
That'd be
like-
awesome.
That would be sweet.
We can make that.
Yeah,
we gotta figure
probably.
out- how would you make that?
Paper mache.
Paper-
No,
I haven't used
I think
paper
I
mache
think-
in like 30 years.
I don't think I've ever properly used paper
Paper
mache.
mache, no way. I think, or here's what you
I
could
was
do.
not an artist.
Maybe you could make I'm thinking of,
I would use cotton balls probably on a board, and then you can make a cross section.
yeah, I guess you could do
That'd be-
something like that.
yeah.
Draw a picture on a piece of paper. That was my
But I'm
go-to
thinking like
method.
Yeah.
a slice down the middle, and you have like the layers and
To be
a
able to
piece
look
of wood
3D
or
into
something.
it.
Yeah,
Right.
Yeah.
I don't
But anyway,
know.
let's go back to
Cardboard
the
or
whole
something.
point of this. So in the atmosphere, there could be a layer of dry air. So if you have a chunk of dry air inside of where a cloud could be developing
Think
or
of
a
like a
storm could be
sandwich
moving
or
in.
something, like that
Yeah.
random piece of tomato or the pickle that you don't like,
Right.
thrown right in there on the burger. Yeah.
So that raindrop falls into that and it evaporates into that dry air. What happens when water evaporates? It cools the air.
down, yep.
Like when you get out of the shower, it feels cold because the water's evaporating off the body.
It's also why we can't cool off on these hot, humid days, because there's so much water already in the air on the humid days. So that evaporative cooling process is a lot slower. We'll get to that at another time. But back to what you're
Yes.
saying. So as the rain comes down into the sand, that little layer of dry air, it evaporates, it cools down. Now you have a cold pocket of air sitting in
Cold pocket of air. What does cold air do? It sinks.
Sinks.
It sinks and it sinks fast. So
Yep.
if you
Yeah.
cool that pocket of air down really fast, really quickly, that sinks fast, and now you create the microburst.
Yeah, or as just an amplification of the downdraft coming out of a thunderstorm. Now
Exactly.
it's just got a little extra boost, like the roller coasters at Busch Gardens when you're already moving forward and then you hit that one little pocket and it boosts you again.
He's the king of
Kinda like
analogies, isn't he?
Oh yeah, 100%.
Well, have you
Pickles, roller coasters.
Do you mind
good, though.
Verbolten, the new one at Busch Gardens?
Haven't been on it.
Verbolten.
I still have yet to go. Period. In general.
Do you like roller coasters?
I love roller coasters. I grew up in New Jersey. We went to Six Flags in Jackson, New Jersey.
Yep. Great
They,
adventure.
by the way, totally off topic. They just took down King to
They took down King to Cobb, which they only built that to make it the tallest and fastest roller coaster in the world, which it never ran. It was always had
Right.
issues with it.
Had-
But
it had issues.
Get yourself out to
Anyway.
Busch Gardens. Lock sponsors got interlocking loops.
Yep.
And the new roller coaster for Bolton.
And
Jeff, I think you'd
anytime
love
that
it.
you're going down
'Cause
quickly,
I like that one.
things.
Yeah.
you'd like
and
that
anytime
one.
you're going down quickly, think of a microburst.
Yeah, there you go.
Yeah.
Yeah. Think of a microburst. All right, what do we got coming up next here?
Okay, we're gonna do a big question now. Do we need to take a break, or are we doing?
Yeah,
Yeah,
real
we
time.
can.
Yeah,
We'll
let's
take a
do
break.
that.
We'll save this next one coming up. Stand by. We will be right back. All right, everybody, we are back taking your viewer submitted questions. We're having a good time here.
Yeah.
This is our best opportunity to kind of nerd out.
Oh, I think so,
totally.
too.
To everybody, yeah.
Totally.
Kind of no prompt off script.
This is
yeah.
a more timely question now. So we've done some kind of sciencey questions, but this is more for current events. I'll read off both questions from both people that asked them, and then we'll just kind of put the answer together. So one from Drew. This is what Drew says. How are forecasts changing due to cuts at NOAA and NWS? How is AI changing the forecasting weather? We'll kind of do that second part later, but we'll focus on the cuts. Another one from AJ is also asking, discuss the impacts of federal budget cuts to NOAA and NWS will have on data assimilation and the impact on accuracy of forecasts for everyday people, particularly with respect to severe weather events. So how are these NOAA cuts affecting our forecasts? Have we seen them? I believe I have seen them, and I haven't even done a study, a formal experiment. I've just noticed how our high-res models and our
struggling.
long-range models are struggling more than they used
And
to.
you know where they're especially struggling with? Timing timing has been huge. At least what I've noticed this spring since I've come here to Hampton Roads. One model will show this timing, and then it could be like 12 to 24 hours out, a time where you would expect to start to get more consistency between models, and you still have like 4, 5, 6 hour gaps in between models. So I think that's at least one thing that I've noticed. The timing has been way off.
And to what you guys were both saying, it's not like we've done a study on it or looked at statistics. It's just we've noticed it because we look at this stuff every day.
Every day.
We look at countless models every day. Let's go back to just refresh. What is a computer model or a forecast model, right?
Yeah.
It's a projection of the future, and it bases its information on what is currently happening in the atmosphere.
We call that initial conditions.
Yep, initial conditions. So computer model, forecast model is just a big computer doing big differential equations. Like a ton of these equations, differential equations, these formulas that are simulating
the atmosphere.
What will happen next based on what is happening now. So the initial conditions that Brian mentioned go into the formula in a certain computer model. It does its numbers, it crunches its numbers, and then it starts spitting out answers. Here's what day one looks, hour X. And then it just all day 2, day 3, day 4 spits out all this at certain time windows, 6-hour windows, 12-hour windows, 3-hour windows, 1-hour windows, whatever. And it gives you a rough projection of what's going to happen in the future. Is that exactly what's going to happen? No, that's not the forecast by any means. We just use them as tools because now it's like, okay, we have so many tools in our toolbox. We have a hammer, we have a screwdriver, but not only do we have a screwdriver, we have a Phillips head and a flathead. We have a level. We have drywall screws and finishing nails. So it's like you have all these tools in your toolbox to build your forecast. But the problem now is there isn't as much data in the initial condition going into those formulas, so those formulas are just there's gaps, and there's not as many numbers going into them.
And they're trying to fill that gap. And as you fill the gap, and as you go farther in time, that small error becomes a much larger error.
It starts
very
to
quickly
compound.
Yes, it does.
Yeah, and that's why we always say never trust a forecast 7 days out or more, and beyond 7 days, because at that point, what do we call it?
Model fantasy land.
Model fantasy land.
The GFS model is a great kind of thing to bring up when it comes to this, because what happens in hurricane season in the months of June or July, we get these 300 hours out. All over social media, people will start to post, and look at this model run of a Cat 5 hurricane coming right into the Gulf, and it's like, slow down.
That's 2 weeks.
That's 2 weeks out, and it ends up not even happening. 9 times at a time.
That's model fantasy land.
So the farther these models put out their projections, right, the answers to these equations that they're doing, the farther in from reality they get. It's just because the small little errors that are factored into these equations start compounding. The best way to steer away from that is to get more accurate data going in initially to the equations. That keeps the models and the equations on track, and those errors aren't as big. But you start taking away that initial data, then those errors start happening a little bit sooner, and they start compounding a little bit sooner. So essentially, what we're saying is like the projection models, the computer models, they're not as accurate. And you're like, okay, well, we've been forecasting, meteorologists have been forecasting for decades. What difference does that make?
Right.
A huge difference.
Huge difference. Some things that we can say that we know and maybe don't know about the cuts that have happened. Some of the cuts, there could be reduced staffing. So if you have a smaller staff, that could mean fewer people that can go out and fix an ASOS weather station that broke down.
Which is recording weather observations.
Observations. There could be fewer weather balloon launches, which weather balloon launches are launched at minimum 2 times per day from several different sites across the country. Now there's fewer sites that are launching weather balloons to save on costs.
And then to get weather observations, to get current data.
And that's the atmosphere. That's where all the weather comes from. It's not just the ground stuff. It's what's happening in the sky.
But
Where's that? Go ahead.
But also, a lot of these cuts with the balloon launches specifically have been areas west of us. Which direction does weather flow?
West to
east. So we're not able to sample as much data out west where the storms are coming from. So for us here on the East Coast, it's going to be even more challenging because we don't have as much data coming from out west where these storms are coming from. So by the time they get here, that's where we get the errors in forecasting. That's where the models have a tough time with either timing or placement, whatever the case may be. So it's all connected.
And we forecasted before we had weather balloons.
Of
and
course.
I would check out the D-Day episode that we did a couple weeks ago because we talked about how they forecasted then, and it's fascinating. So we'll save that. Go check that one out.
But how they forecasted then, and how people may bring up the question. Well, we forecasted for decades here, so why does this matter? Yes, we did, but the forecasts just weren't as accurate. It's doable,
Right.
Yeah.
but they just weren't as accurate. And you know what they were using to forecast weather? Weather observations. That's what
Exactly.
they were using. What is
Yep.
happening upstream
Yeah.
is going to happen downstream. That's how they kind of projected out the future here. So it's an interesting thing, and I'm going to be interesting to see how it plays out with hurricane season, because one of the main reasons why hurricane forecasts in terms of track and intensity, why they've improved so much over the past decade to two, the hurricane hunters that go out and collect the data in the hurricanes, providing instantaneous information to get just most up-to-date and most high-resolution projections of what could then happen with a hurricane. So that'll be my question is
Right.
how are we going to see that then on out?
What's going to happen with that?
What's going to happen with that? Because if a tropical cyclone or something rapidly intensifies, let's say in 36 hours, which we've seen happen over open water, but imagine if that happens 36 hours out from making landfall. Somewhere, and you're expecting a high-end tropical storm or Category 1, like, oh, we can handle 90-mile-an-hour winds. That's no problem. We can handle 100-mile-an-hour winds. Minor storm surge, like, we'll be all right. But there isn't a hurricane hunter flight that goes out to collect data within the next 12 to 18 hours, and then there's a miss in the data, and then all of a sudden you wake up the next morning and that expected Category 1 is now Category 3. It's a major hurricane. So
big time
these
changes.
are all hypotheticals.
Right.
All hypotheticals, but that's just kind of where my mind goes. So it's interesting. Very interesting.
I wonder, this is just kind of me throwing stuff out there. Are we 10 years backwards now with our quality of forecast? Are we 20 years back in time?
That's a good.
Unfortunately, I think only time will tell when it comes to that.
Yeah.
If it continues to be a problem with the cuts, we'll see.
Because I remember using back in college, it was a frozen model at the time. But yes, Don Slater, Jeremy Wheeler, because they were more meteorologists during this time. The NGM model was something that was used. It's a retired model. It's not run anymore, but that was an older model. Models are built on a set of data, a timeline. They say like, oh, look at all this information. Look at all the storms and possibilities that have happened. And then the equation is built on that, like Steve talked about earlier. So newer models have more data, more layers, more resolution. They've gotten better, but now since they're missing that data, they're not performing as well. So this kind of goes to the part 2 of Drew's question. How is AI changing forecasting weather? Essentially, models were kind of built on what AI is
Now,
in a way.
Yeah.
It's just a new term. It's a way to kind of simplify it because we are starting to understand what AI kind of is. It's moving so fast. But so yes, models are built kind of on what's happened in the past and what could happen based on those prior situations. They always don't do a good job, but prior situations. There are some new models that are always being built. I know the European model has an AI forecast system that they're kind of testing
That's
right
what
now.
I think.
Testing it out.
I think that maybe that there might just be more options in terms of forecasting models that come out, because it might be easier to build said model out with the help of AI in a way. So maybe that's where I think there might be a change. That I don't know if it'd be a bad change. I think it'd be more information could be more helpful, but also at the same time, maybe more information might not be as helpful. So there might be more
I don't know.
misinformation
Maybe it could
coming
fill,
from
maybe
it.
the AI models can help fill in the gaps where the deterministic
Maybe
ones lack.
or maybe not.
be.
Maybe they
I don't
just
know.
spit out. Maybe they spit out Model Fantasyland at day 5
Yeah.
instead of day 14.
Look,
and
we're
you never know.
and we're still in the
That sounds fun.
very beginning stages of kind of digging into the AI models to see what they're kind of up to. So we're again the very beginning stages, and it's another one of those things where time will tell, and how will it improve over the course of maybe the next 3 to 5 years. It's already kind of advanced so much in the past couple.
Yeah.
So who's to say what could happen in the next 3 to 5?
Yeah, I didn't go to school to learn how to build models. I went
No.
to
Me
neither.
school to learn how to
Me
forecast
neither.
from them.
Yeah,
So
exactly.
And that's
it's tricky.
why we're here, to be able to forecast from them and be able to communicate that. Because we could all access and look at a day 8, 9, 10, 12 projection from a model, and you go do it yourself if you want to, and look at 3 or 4 of them and notice how they are all different.
Yeah.
And you're like, well, and it's guess what? It's not going to answer your question of what's going to happen.
I hope that answered the question from AJ and Drew. I mean,
Yeah,
that's
it's
what we
kind
know
of
right
tough.
now.
Yeah, and maybe AJ said particularly with respect to severe weather events. I mean, you mentioned the staffing. If there's shortage in staffing to, that just may put more stress on staff that's there to issue warnings and to put out watches and to be the communicators of severe weather events. And then the data we talked about.
And no one thinks about this, but also answer the phone. At those NWS offices, they get calls in all the time,
Yes,
especially in
true,
severe weather events. If some people want to call in and ask about their specific area or what the threats are for
storm
storms,
reports.
or
From a
storm
police department or
reports,
something. Yeah.
Less people means you're not going to get, there's not going to be that access to information.
Yeah.
Yep.
Some calls might go missed.
Yeah.
So that's
so it's
one,
interesting.
That's a concern.
Yeah, it's interesting.
Definitely a concern.
Drew and AJ, thank you both for asking that question and honestly having BTF to be able to talk about it too.
I was excited for that discussion.
Yeah, because
Yeah.
it's a long answer and it's something that we may not be able to talk to so much of on air, but here in this platform, I think we're able to chat about it conversationally, and I think it's great.
Maybe something that we'll touch back on in a couple of months and see what's going on.
Yeah,
We'll know
absolutely.
more. We'll know more. This kind of goes into the next one from Michael. Why does it seem that all meteorologists just seem to guess at our weather, especially in the 757? Because I know it's never on point, and that's what you all predict.
That's the one you didn't want us to read.
That's the one I didn't want you to read. That's the one he tore off the top of
ripped
his
my
page.
paper
I wanted to
because
see.
Jeff was like, "Don't look at this one."
We're
question.
doing all the questions.
I don't
These are all
even
the
remember the
questions.
question he asked. Why are we all wrong? Why were we just guessing?
I'm not wrong.
Jeff's never wrong, guys. He's the chief.
Yeah, right. No. Part of it goes to, I would say part of it goes to the NOAA cuts, very small part. I'm not going to blame it all on that.
Yeah.
Not going to blame it all on that, but that has increased the inaccuracies and timing of thunderstorm arrival. I've noticed here in the last couple of weeks, throughout the spring and into summer season. Part of it too, this is a tough area to forecast
Very
for.
tough.
Yeah.
I mean, I want to see someone nail it every time. It's
Think
tough.
about where we
Especially
live.
in the summer. The summer is just intense.
Not even the summer. Think about where we live when it comes to the spring and the fall seasons when the jet stream is going all over the place.
Yeah.
The jet stream heavily influence our weather. Big ridges can lead to warmth. Big troughs can lead to outbreaks in cold air. And in between that, you got big time storms. So it's kind of, we live in an area where we are highly prone to fluctuations.
Yep.
And on almost a weekly to daily basis.
Also-
So it makes it very challenging.
And one forecast every day our forecasts are always going to be incorrect because if you live a mile away or on the shore, it's going to be a cooler day or whatever.
Right.
And then you live a few miles inland and it's stifling hot. I mean, it can be totally different.
So I'm gonna flip it around here and say, it's always I think all the time when someone asks, someone here at work, they'll say, "Is it gonna rain tomorrow?" I always say, "When and where?"
Yeah.
Like, where are you asking? When are you asking it about?
Yeah.
Because those specifics matter.
Very important.
Yes, they
here.
do.
If you have those specifics in mind when you ask that question or are interpreting the forecast, I bet those forecasters are going to be a lot more accurate than you think.
Can you put the camera to a wide shot where we can see all the chairs?
Camera to a wide shot.
Just one, just
What-
grab
yeah,
a,
what is it,
just
the
punch
cam one or
a punch a
two?
wide shot.
Punch a wide
Yeah.
shot. Let's
Yeah,
see if
punch
we
a
can
wide
do.
shot.
There we go.
No, not that one. No,
that
do one where you
One
can see
from
this
the
chair.
wall?
Yeah, do
Yeah,
the
the
wall
one
cam.
from the
Do a wall
wall.
cam.
Yeah,
There we go.
there we go.
Perfect. So take your classes, your dynamics classes,
Oh, there
your
you go.
synoptics classes. We have a chair right here for anyone to come and forecast with us. So
a scolding lesson from professor sophomore year.
yes, we have a chair right here. So we all went through it.
Another
Yep.
class thrown in there just because problem sets here or there.
Jeff
Yep.
really wanted to do that.
Yes,
Yeah.
I really wanted to pull out the chair. But yeah, that's seriously though. I mean,
No, I think it, and honestly, I'm going to answer that question by saying I think it has a lot to do with the interpretation of the forecast as well.
Yep.
What information are you actually trying to get out of it?
Right.
Because, like you said, I mean, you living at the beach, you inherently know it's going to be a little bit cooler just based on which way the wind is blowing here or there.
Yeah.
But like you're like, when is it going to rain? Or is it going to rain tomorrow on my event? Be like, okay, well, when and where is it? And then we can help you guide you through the forecast or whatnot here. I'll go back to an example. I was at a Cure Coffee Shop down the street.
Yeah.
And the owner popped out and he was saying how, man, I thought it was going to be like 80 all week. And all of a sudden, forecast changed. And living so close to the water, that happens in
Yes.
a 72-hour window. So I think Monday we were forecasting a lot of sunshine, maybe temps in the 80s for most of the week. And then Monday afternoon, Monday evening rolls around. Don and I were like, ooh, is there a wind shift coming up on Wednesday? Okay, let's hedge it a little bit because if there is a wind shift, that's going to drop temps. So we dropped temps a little bit, hedged it just to not throw everyone for a complete loop.
Yeah.
Tuesday it rolls around. It's like, there's that wind shift. And we're like, it's going to be cloudy and cool for the rest of the weekend.
Yep.
Just like that.
Boom.
Because of a slight wind shift. And that was all because a front changed by 20 miles. And that was it.
And
that was it.
But
And
this
that was
is
it.
also why like initial conditions are so important when it comes to kind of going longer range in our models, because the weather is a chaotic system. It is always changing. Your initial conditions are always changing.
Yeah.
From now to now.
Yeah.
It has
Yeah.
changed. So that's going to, an hour ago, the initial conditions are one way. Now they're a different way. An hour from now, they'll be a different way. So the models are going to be changing all the time. And especially where we live, where they tend to fluctuate a lot, especially in certain times of the year, it can make for a more challenging forecast.
Yeah. Yeah. Oh, yeah. Especially in this area here. I also say that's our job, too. We have to find a way to communicate it to everyone so that it does come off accurate so that people can plan their day and they
Communicating
can
the
know,
confidence level,
communicate the
too.
confidence level. You
Yeah.
know, that's the difference between saying thunderstorms are rolling in between 3 o'clock and 5 p.m. It's like, well, you just put yourself in a 2-hour window. Difference between saying that and saying, there's going to be some thunderstorms after 2. Sometimes simplifying the communication helps people better understand what is going to happen so that they'll go out to start their day. They're like, let's use Thursday, for example. Storms coming in around sunset. Okay, so thunderstorms are coming around sunset. Okay, now I know I have all day to stay dry, and up until about sunset when sun starts to
gets
go
low.
down,
Yeah.
okay, that's when they said storms are coming in. And it's like, okay, guess what? That's okay. And that's going to be, that's what it has to be right now. But I think
Yes.
the thing is everyone wants everything as soon as they want it. They want it now.
Yep.
They want more information. They want it now.
they want it on
why,
the dot.
Why I wanted 3 pickles on my burger.
Yeah.
Now I only got 2.
Michael also asks a question. Question 2. What happened to all the pretty meteorologists? Whoa, wait a minute.
What? Is Jeff not pretty? Come on. Steve's
What's
out of here.
going on?
Steve's leaving.
Yep, Steve's
Steve
outta
is
here.
out of here. He's gone.
All right, well.
Bye,
see,
Steve.
Look what happened. Look what happened.
You guys made him upset.
Well, yeah, we're going to we'll do a quick break. We have some more questions here. We'll be right back.
Sweet. All right, we are back, everybody. Welcome back to Beyond the Forecast. We're answering your questions.
Are we
We've
pretty
had a
yet?
lot of fun. Steve still is upset about not being pretty. Is that
The
what's
previous
happening?
question was what happened to all the pretty meteorologists? I guess, yeah. Are we pretty yet?
I don't know.
Hang on, wait. Now we're
There
pretty.
There we go.
Now
Yeah,
we're
okay.
talking.
Yeah.
Okay,
Take off the
all right.
glasses.
Yep.
Yeah, I have contacts, so
Well, no, I'm
not
just
gonna
saying
say
I
much.
can't see everyone. So
Oh,
now
yeah,
everyone's
there you go.
pretty.
Yeah.
There we go.
Okay, Mike Staples, he asked me this question a couple weeks ago. I wanted to get to this. When is a new moon? What is a new moon? We use the term new moon. NASA uses the term new moon to talk about a lunar cycle. So we have a new lunar cycle. We go through all the moon phases, first quarter, last quarter, full moon, all those phases. We get to a new moon phase. That's when we call it, that's why we call it that.
Because the moon is rotating around the Earth.
Yes, and that orbit, now I had to get this so I get this right. The orbit around the Earth is 27.332 days. It's an elliptical orbit. So like
All
a
of us-
football.
all
Yep,
of us
all
just
of
doing
us.
this.
Yes, like a football. But
Johannes Kepler discovered that things orbit elliptical, not
the
cylindrical.
time from a new moon to a new moon is 29.5 days. There's a difference in that time scale.
So the orbit's roughly 27 days,
Yes,
but the new moon cycle is every 29 days.
right.
Okay.
Elliptical orbit.
Elliptical orbit.
Because the moon is tidally locked to Earth. Do you know what that
okay.
mean? Have you heard that term before?
Yeah,
Tidally
heard of
locked.
the term.
I
Heard of
haven't.
the
It's
term.
always facing the same.
Same-
We're
oh,
always
oh,
the same side.
that's right. Yeah,
Yeah.
you always see the man with the cheese.
You never.
Yes.
Yeah,
the man
you,
with the cheese is
You
that
don't
what
see
it
the
is?
far side of the
the,
moon.
the
Right.
back side
Yeah.
of the
No, I
moon
see-
you never see.
Dark side of
the moon.
The dark side of the moon.
Pink Floyd, right? Dark
Yes.
side of the moon.
Far side of the moon.
Far side? Far
Yeah.
side.
Well,
not
Dark Side of the Moon. Wasn't that the Pink Floyd album?
Yeah. that's
Okay,
music,
good, but it's
yeah.
technically called the Far Side of the Moon.
Far side of the moon.
Got it. Okay.
Yeah, it's kind of like, let's say you're going out with someone and you just can't take your eyes off of them.
You're locked on them.
Yeah. Hey.
Got it. Okay, cool.
Us
So
when we look at
tidally
Steve-
locked. So
us
that's why
looking
it's a
at
little
Steve
bit
'cause
longer.
he's so pretty.
Title, but the elliptical orbit is the primary
Is the
reason.
primary
Yeah,
reason.
that's pretty
Okay.
much the
That makes
reason.
sense.
Yeah.
All right, cool. Love
Kind
it.
of fun. Yeah, I love a little astronomy every once in a while.
And this is another great question. Paxton sent this one in. I had another question as well asking about percent of precipitation. We call that POP, percent of precipitation.
This can kind of link back to the why are meteorologists
Yeah,
wrong?
because I remember at Harborfest,
Yes.
someone had came up to you and said, "You are always wrong,"
You're always wrong.
and
Yeah.
said something about the rain, and then you had said, "Hang on a second, let me. This is what we mean when we say that." Oh.
Yep.
So back to the interpretation of the forecast, right? Does 80% chance of rain mean there's an 80% chance that rain will happen in a given area? Or does that mean 80% of the forecasted area will get rain? I think the latter is the
Yes.
best way to
do it.
describe
Yep.
chance of rainfall. Meaning
Coverage.
that coverage. Meaning, here's the thing. We have to go on air and confidently talk about something that's going to happen in the future. It's not easy. So we spent a lot of our shift forecasting and actually doing the job of making that forecast, that projection of the future. So when we go on air, we're pretty confident about what we think is going to happen in the next 24 to 36 hours and then some.
Essentially,
We will communicate if we're not confident or not, but we're 9 times out of 10, we're confident in it. So the technical formula of POP, correct me if I'm wrong, isn't it confidence by area? Right?
That's what I use.
Those are-
percent confidence.
Two of the
like,
big variables.
Do you
in
have an
that.
ink pen or crayon or
It's
colored
like
pencil
percent,
or
the
marker?
percent
Gotta-
you're,
yeah, here.
how confident, and
Toss it over.
percentage, how confident are you of a chance
Thanks.
of rain? Multiplied by the percentage of the forecasted area that will get rain. So if we are pretty confident to be on air to talk about a forecast, that first variable in that formula is basically 100%.
Right.
Because we're more often than not, you're 90%, 100% confident in the forecast moving forward. So, okay, that's going to be usually about 100%. So the next variable that you're multiplying 100% by or 1 by is the percentage of coverage of the forecasted area
Right.
who gets rain.
Yes.
So it's best to kind of think of an 80% chance of rain, meaning that 80% of the area we're talking about will get rain at some point during the day, and then you clarify what time, when, for
Right.
how long.
If we live, if Hampton Roads and the whole area is a piece of paper, a big rectangle
Can
essentially.
you see the lines on there?
Yeah, you can kind
I'll
of see the
hold it
lines.
closer.
Yeah, hold a little closer. So we can quarter it out. So we could say the bottom half would be 50%. I actually don't use the term 50% because I feel like it's so
don't
misunderstood.
either. I mean,
then
we
they say
could-
50, 50, 50, 50.
Yeah, technically in our definition of percent chance of year, if we're talking about coverage, yes, technically we could say 50% of the area will get rain.
Right.
But I was like, day one in meteorology school was like 50% chance of rain. I mean, it was like, well, it's just like a coin flip, 50-50. So
Right.
it's like you either go on either side of
You take either
50
side.
degrees. Yeah.
So think of our area as a big rectangle. It isn't.
Right.
Because there's so many spots: Eastern Shore, peninsulas, North Carolina, Outer Banks, South Side. But break it down like that, and then that's how we forecast that percentage.
So, like,
very, very simple way,
So
very crude way.
if there were 3 of these boxes, there's going to be rain in tomorrow. 75% chance of rain because
Yep.
3 of these boxes cover 75% of the area. That's how you think about it.
Mm-hmm.
So if you see 80% chance of rain on the 7-day forecast, you go, "Ooh, that's good. Is it going to rain all day?" No, that just means 80% of us are getting rain
At some
and
point
then
in the
if
day.
you were paying attention to the previous 3 minutes of the forecast that we're talking on air, there would have been a specification of when,
Yeah. Timing.
and then maybe who,
And
if
maybe
we could
if we're
verify
confident,
an area.
And maybe, if we're confident enough in where it's going to happen, then we'll give that information as well.
Yes. So the number itself is only giving you how much of the area will get rain, but it doesn't specify who, and it doesn't specify when, and it doesn't specify how much, and it doesn't specify for how long. So that's 4 things that you're not getting out of an 80% chance of rain. So think of that the next time you look at your weather app. Go, oh, this says, this said 40% chance of rain, and it's pouring on me right now. Why? I don't,
You
Be-
happen to be in the 40%
you
of the
happen
area.
to be in that 40% of the area
Meanwhile-
at that right time, under a thunderstorm. What
And
was
that's
the
why
environment?
a lot of times we'll get, calls in saying, "Oh, like you guys called for an 80% chance of rain and it didn't rain a drop at my place." It's like, well,
Yeah.
a lot of times you're just in the 20% of the area that just didn't rain.
Didn't get rain.
When those
Yeah.
phone calls come in, I just give you to the phone. And,
Yeah, that's-
I say,
that's
We
about
handle
right.
them.
Let's get you to a meteorologist, and they don't know who I am. So, anyway, good questions.
Yeah,
Great
that's
question.
great.
Good questions.
This is
Fantastic.
great.
There's more on here. We don't have enough time right now, but shout out to Robbie, shout out to Chris McDonald, talking about urban heat islands
Oh,
and
wait, one more.
oysters.
John Ravenholt. What
Oh.
does winds aloft mean?
we get-
Aloft is just
Upper levels.
Upper
levels.
Up, really, really high in
Yes.
the altitude.
Yeah.
Just up.
In the
You hear
cloud.
aloft,
Yeah.
just way
Above
up
the
there.
cloud even. Yeah. That's what that means.
We'll go more into detail about winds
Yeah,
aloft.
but we
next time.
got great stuff about tides. We're going to talk about next time we do one of these, and urban heat islands, because those are big topics.
Big
They're fun stuff.
snowstorms.
Yeah.
Yeah, snowstorms too.
Yeah.
How we get big snowstorms. We can pull some of the pictures from our last snowstorm. But that's all we got for now.
Yes,
Good.
great.
Yeah, I
Loved
think
it.
this
We're
is great.
good.
Thanks to everybody for joining. We'll do this again in the future. This was a lot of fun.
This was a good time.
Yeah, tune in next week for Beyond the Forecast. We love doing these, and we definitely send us in any of your questions. Social media
Yeah.
being the
Yep.
easiest way to do it. Steve, what's the other method? The
Email.
method?
Yeah, you can email weather@wavy.com.
Cool. All
Cool.
right, everybody,
Rock
thank
on.
you so much for tuning in to Beyond the Forecast.